Single displacement reactions where anions are now being exchanged. Alright, so in this case, you still have an ionic substance that is combining with an element in its neutral state, but now it's the anionic portion of the ionic salt that exchanges with the element. And that means that the anions are now going to be changing charges. But at the same time, that means that the cation doesn't play a role. It's innocent from the point of view of the reaction. It just remains kind of like a spectator. So its charge will not change. And specifically, this is going to happen whenever the free element on the reactant side, C, is a non-metal other than hydrogen, right? Because if it is hydrogen, the reaction will be the exchange of a cation. All right, now we don't exactly have an activity series for the non-metals. The reason being that you just need to look at the periodic table. It's actually laid out exactly in that way. For instance, if you look at the halogens, the order of the activity of the halogens is exactly the order in which they appear in the periodic table. So fluorine is the most reactive, followed by chlorine, followed by bromine, and ending with iodine and astatine. Okay? So if we do a reaction where difluorine is reacting with magnesium bromide or dichlorine is reacting with scandium bromide, the idea is pretty much the same. We ask ourselves for the free element. Is the free element higher on the list than the element inside the ionic substance? And since this is not dihydrogen or a metal, we will be doing an anion exchange. Okay, so it is indeed that fluorine and dichlorine are above bromine, so a reaction will happen. Now the cation is going to remain exactly the same. It will not change its charge. So magnesium 2 plus on the reactant side is still magnesium 2 plus on the product side. The difference now is that this will be mixing with fluoride. Okay, so now the fluorine changes its charge. It is now negative, and it has to be negative because it's now the anionic component. If you're not sure about what the charge is, remember that group number -8 will yield the negative charge of the anion. Bromine, on the other hand, is now going to be all by itself, and since it will be neutral, it has to be present as a diatomic molecule, and being bromine, it also has to be a liquid. Okay, similarly speaking, dichlorine will react with scandium bromide to give you scandium still in its 3 plus state, right? That's the charge of the group number scandium is present in. And now this will be mixed with chloride. Okay, so chlorine that was neutral now will have a charge. Its charge is group number -8, in other words, -1. You only bring the unit, by the way. Keep in mind that at this stage, you don't want to bring anything else other than the unit, right? So don't bring the subscripts if they are not needed. The bromine, once again, will be displaced and it will be all by itself, meaning that we still have to write Br2 liquid for the product. Now we're going to use the charges to tell the portions. The 2 of magnesium goes in front of fluorine, the 1 of fluorine goes in front of magnesium. The 3 of scandium goes in front of chloride, and the 1 of chloride goes in front of scandium. So you end up with the following structures: magnesium fluoride and scandium chloride. Alright, now if we look at the first equation, we'll realize that we have 2 fluorines on the left side, 2 fluorines on the right side. 1 magnesium on the left side, 1 magnesium on the right side. 2 bromines on the left side and 2 bromines on the right side. So the equation is balanced. Looking at the second equation, we have 2 chlorines on the left side, 3 chlorines on the right side. So we have this even odd business. So we want to multiply the first one by 3 and the second one by 2. Alright, and then we look at the bromines, same idea. 3 bromines on the left side, 2 bromines on the right side, so we want to cross multiply those two to get the bromines balanced. So we multiply the first one by 2 and the last one by 3. And then notice that now we have 2 scandiums on the left side and 2 scandiums on the right side. The equation is now balanced. And this is how you go about determining the products of a single displacement reaction in which anions are being exchanged.